Hello learners! Good day and welcome back to General Mathematics Learn by Video series. This is brought to you by QuexBook Smart Mobile Learning and PerkDC Learn Hub. You're still with me, Engineer Rex Jason Agustin, and this is already our fourth lecture video on simple and compound interest. This video is just a continuation of our discussion on simple and compound interest, which is under the second part of our General Mathematics for Grade 11 Senior High School students, Basic Business Mathematics. Before we proceed, please get your pen, paper, and also your calculators. Alright? Our most essential learning competency computes interest, maturity value, and present value in compound interest environment. The topic outline would be, first, we're going to have compounding once a year, and then we're going to have compounding more than once a year. In line with our MELC, our learning objective is, at the end of the lesson, the learner is able to compute interest, maturity value, and present value in compound interest environment. Compound interest. From our previous lecture videos, we learned that compound interest is calculated on the principal amount and also on the accumulated interest of previous periods and can thus be regarded as interest on interest. In other words, at the end of each period, the interest earned is added to the original amount and the money is reinvested. In solving problems involving compound interest, we use the formulas F is equal to P times quantity 1 plus I raised to N, or transposing, we have P is equal to F over quantity 1 plus I raised to N, where F is the future value of money, P is the principal or present value of money, lowercase I is the interest rate per period, and N is the number of periods. Let us have example number 1. Find the maturity value and the compound interest if 10,000 pesos is compounded annually at an interest rate of 3 years in 5 years. Let's take note first of what are the given. We have principal P, 10,000 pesos. Interest rate I is equal to 3% annually. And N is equal to 5 years. We are required to solve for two things. First, the maturity value or the future value. And second, the interest earned. Okay? For our solution, for the maturity value, we use the formula F is equal to P times quantity 1 plus I raised to N. Just substitute the given, and we will have F is equal to 10,000 times 1 plus 0.03 raised to 5. The maturity value is 11,592.74. Okay? And for the compound interest, we know that maturity value is equal to principal plus the earned interest. So we can say that the interest earned is equal to the maturity value minus the principal, right? Interest earned is equal to 11,592.74 minus 10,000 pesos. The interest earned is 1,592.74. Next, example number 2. What is the present value of 200,000 pesos in 7 years if money is worth 8% compounded annually? We have the following given: future value or maturity value 200,000 pesos. This is not the present value. It says here, what is the present value of 200,000 pesos? We are being asked for the present value, so definitely this 200,000 pesos is not the present value, okay? That is our maturity value F. We're also given I, or interest rate, 8% annually, 8% compounded annually, and N is equal to 7 years. Okay? We are required to solve for the present value or the value of the principal P. For our solution, we use the formula P is equal to F over 1 plus I raised to N. Just substitute the given. We will have principal or present value P is equal to 200,000 over 1 plus 0.08 raised to 7. The present value is 116,698.08. Alright? Let us have example number 3. If 10,000 pesos becomes 17,623.42 after n years, when invested at 12% interest compounded annually, determine n. We have the following given. P, or the principal, is equal to 10,000 pesos. F, or the future value, is 17,623.42 pesos. I, or the interest rate, is 12% compounded annually. And we are asked to determine the value of N. For our solution, we note that future value F is equal to principal P times quantity 1 plus I raised to N. We are going to determine the value of this exponent N, okay? We can transpose P to the other side of the equation, and we can write it as F over P is equal to 1 plus I raised to N, okay? Then, we need to recall that log of x raised to n is equal to n log x. Do you still remember this one? You had this during the discussion of logarithm. It's one of the properties of logarithm. Okay? So taking the logarithm of both sides, log of 1 plus I raised to n is equal to log of f over p. We will have n log of 1 plus I is equal to log of f over p. Then we just need to transpose log of 1 plus I to the other side of the equation so we can isolate n. We will get n is equal to log of f over p over log of 1 plus I. Okay? Then we just need to substitute the given, and that would be n is equal to log of 17,623.42 over 10,000 over log of 1 plus 0.12. Okay, just press this in your calculator and we will get n is equal to 5. Okay, so the value of n is 5 years. Okay, before we proceed to our next slide, please take note of this formula. N is equal to log of f over p over log of 1 plus I. Okay, you may add this to your list of formulas for compound interest. So far, what we had solved are all just about compounding once a year. Now, in our next examples, we will be solving problems about compounding more than once a year. Are you ready? Alright! In the previous examples, we used the formulas f is equal to p times quantity 1 plus I raised to n, or p is equal to f over 1 plus I raised to n. Now, we just have to note that interest rate per period I is the quotient of nominal rate R and the number of interest periods in a year M. I is equal to R over M, where M is equal to 1 if the mode of interest is annually or yearly. So if the mode of interest is yearly or annually, we just substitute 1 here for M. And that makes it I is just equal to R. That's what we've been using, or that's what we've observed in all of our previous examples. Okay? M is equal to 2 if the mode of interest is semi-annually or every 6 months. Semi-annually means twice a year, and that is every 6 months. Okay? M is equal to 4 if the mode of interest is quarterly. We have 4 quarters in a year. That is every 3 months. Okay? 1 year has 12 months. So 12 months divided by 4 quarters. 1 quarter is equal to 3 months. And M is equal to 12 if the mode of interest is monthly. Okay? And we also note that nominal rate R is the annual interest rate stated on loan, usually in percent, charged by the lender, or the rate of increase of an investment without adjustment for the full effect of compounding. Okay? And number of interest periods N is the total number of interest periods for a loan or investment. That is just simply N is equal to M times T, where M is the number of interest periods in a year, depending on the mode of interest, if it is quarterly, 4, or monthly, 12, semi-annually, 2, or annually, just 1, and T, which is the number of years. Okay? N is equal to M times T. So, we can write the formulas as F is equal to P times quantity 1 plus R over M raised to MT, or P is equal to F over 1 plus R over M raised to MT. We just replace I with R over M and N with MT. Okay? Where F is the future value of money or the maturity value, P is the principal or present value of money, R is the nominal rate, and M is the number of compounding periods in a year, and T is time in years. Okay. Okay, let's try using those formulas in this example. Example number 4. Given the principal of 10,000 pesos, which of the following options will yield to greater interest after 3 years? Option A, earn 2% compounded annually, or option B, earn 2% compounded semi-annually. For this problem, let's take note of the given. We have the principal P, 10,000 pesos. T is equal to 3 years. And nominal rate is 2% or 0.02, right? For our solution, let us first consider option A, which is 2% compounded annually. Let's have this table so that we can clearly see what's happening with the investment, okay? In the first column, we have period, first year, second year, and third year. The money is invested for 3 years. On the second column, we have interest gained at the end of each period. Okay, at end of each period, interest is equal to P times I times N. Okay? And then on the third column, we have amount at the end of each period. Future value is equal to principal plus the interest earned. We note that in compound interest, the interest is computed every end of each interest period, and the interest earned for that period is added to the principal. Okay? So for the first year, the interest earned is 10,000 pesos times 0.02 times 1, which is equal to 200 pesos. At the end of first year, the money will be 10,000 plus 200. That is equal to 10,200 pesos. Okay? No problem with this one. For the second year, the interest earned is 10,200 times 0.02 times 1, which is equal to 204. Okay? For N, we use 1 because it says that in compound interest, interest is computed at every end of each interest period. We use here 1 and not 2 because this is just another 1 year, the second year. Okay? And for the principal, we use 10,200 because in compound interest, the interest earned for that period is added to the principal. Okay? So we use here the value of money at the end of first year as the principal for the second year. Okay? So at the end of second year, the money will become 10,200 plus 204, which is equal to 10,404. Okay? For the third year, the interest earned is 10,404 times 0.02 times 1. Okay? The interest earned for another 1 year, the third year. Okay? And the principal that we use here is the value of money at the end of second year. Okay? The interest earned for third year is 208.08. The value of money at the end of third year is 10,404 plus the interest earned during that year, 208.08. That is equal to 10,612.08. Okay? We can actually get this same answer if we just use the formula F is equal to P times quantity 1 plus I raised to N. I just use here the subscript A to note that this is the future value that we will have if we consider option A. Okay? Future value is equal to 10,000 times 1 plus 0.02 raised to 3. Okay? That's 10,612.08. The same with this one. Okay? So the interest earned after 3 years is future value minus the principal. 10,612.08 minus 10,000. For option A, the money will earn 612.08 total interest for 3 years. Okay? Now for option B, 2% compounded semi-annually, we need first to compute for I, which is R over M. Since this is compounded semi-annually, M is equal to 2. I is equal to 0.02 over 2. That is equal to 0.01 or 1% every 6 months. That is 1% after 6 months and 1% after another 6 months. We also note that N is equal to M times T. M is equal to 2 for compounded semi-annually and T is equal to 3 years. So N is equal to 6. That means there are 6 semi-annuals or 6 interest periods in 3 years. Okay? Let's make this table again so we can see what's happening with the investment. On the first column, we have period, first, second, third, fourth, fifth, and sixth. There are 6 semi-annuals or interest periods in 3 years. In the second column, we have interest gained at end of each period. And on the third column, we have amount at the end of each period. Okay. Let's note again that in compound interest, the interest is computed every end of each interest period, and the interest earned for that period is added to the principal. So for the first period or the first 6 months, the interest gained is 10,000 times 0.01 times 1. Okay, the first 6 months is 1 interest period. Okay, the interest earned for that period is 100 pesos. So after the first period or the first 6 months, the money will become 10,100 pesos. For the second period or the second 6 months, okay, the interest gained is 10,100. Okay, we use here the value of money at the end of first period. Okay, that's the principal for the computation that we have for the second period times 0.01 times 1. Okay, another 1 interest period, the second 6 months. Okay, the interest earned is 101 pesos. So at the end of second period, the value is 10,100 plus 101. That is equal to 10,201. Okay? For the third period or for the third 6 months, the interest gained is 10,201. This is the value of money at the end of second year times 0.01 times 1. Another interest period, okay, the third 6 months. The interest earned for the third period is 102.01. Okay. So the future value at the end of third period is 10,201 plus 102.01. That is equal to 10,303.01. For the fourth period or for the fourth 6 months, the interest gained is 10,303.01. That is the value of the money at the end of third period times 0.01 times 1. Okay, interest gained at end of each period. That's 103.03. The value of the money at the end of the fourth period is equal to 10,303.01 plus 103.03. That is equal to 10,406.04. For the fifth period, the interest gained is 10,406.04 times 0.01 times 1. That's 104.06. The value of money at the end of fifth period, that's 10,406.04 plus 104.06, which is equal to 10,510.10. Okay? And for the sixth period, this is our last 6 months. That's 10,510.10 times 0.01 times 1. The interest gained for that period is 105.10. So at the end of the sixth period, we have 10,510.10 plus 105.10. That is 10,615.20. Okay? So after 3 years, the money, if invested at 2% compounded semi-annually, will be 10,615.20. We should get this same maturity value, even if we use the formula future value F is equal to principal P times quantity 1 plus R over M raised to MT. I just use the subscript B to indicate that this is the future value if we considered option B. Future value is equal to 10,000 times quantity 1 plus 0.02. This is our nominal rate of interest, 2%, over 2. Okay, M is equal to 2 for compounded semi-annually, raised to 2 times 3. Okay, 3 years. Okay, using your calculators, you should still get 10,615.20. Okay, so for option B, the total interest earned is equal to 10,615.20 minus the principal 10,000, that is 615.20. Again, the interest earned if we considered option B is 615.20. Now, going back to the question, which option will yield to greater interest after 3 years? Is it option A, earn 2% compounded annually, or option B, earn 2% compounded semi-annually? We were able to compute that the interest earned for option A is 612.08 pesos, and that the interest earned for option B is 615.20 pesos. Since the interest earned for option B is greater than the interest earned for option A, our answer is option B. Option B yields greater interest after 3 years, right? Now, before we proceed to the next slide, I just want us first to take note of what we have observed in example number 4. And what is that, sir? We note that if all else is equal, a more frequent compounding will result in a higher interest. Okay? So if we will be asked in the future, which will yield to higher interest? Is it 10% compounded quarterly or 10% compounded monthly? That would be 10% compounded monthly. Okay? Okay. Example number 5. What is the future worth of 12,000 pesos deposited in an account earning interest at rate of 9% compounded quarterly for 8 years? Let us take note of the given first. We have principal P, 12,000 pesos. Okay. Nominal rate R, or the stated yearly interest, 9% or 0.09. M is equal to 4 for quarterly. It says here compounded quarterly. T is equal to 8 years. And we are required to solve for the future value or maturity value F. Okay, what is the future worth? For our solution, we use the formula F is equal to P times quantity 1 plus R over M raised to M times T. Okay, we just need to substitute the given to this equation, and we will have future worth F is equal to 12,000 times quantity 1 plus 0.09 over 4 raised to 4 times 8. You may just simply press this in your calculator and you should get the answer 24,457.24. Okay? Example number 6. A man possesses a promissory note whose maturity value is 6,700 pesos due in 3 years hence. if the rate of interest is 10% compounded semi-annually, what is the value of this note now? What are the given? We have future value F, 6,700 pesos. Okay. It says here 6,700 due in 3 years. Okay. So this is not the present value. Okay. This is in the future. That's future value F. Okay. Nominal rate R is equal to 0.10 or 10%. Interest is 10%. Okay. M is equal to 2 for semi-annually. Says here compounded semi-annually. Okay. And then T is equal to 3 years. And we are asked to solve for the principal P. Okay, that's here. Okay, we are asked what is the value of this note now. Okay, that's the present value that we need to solve. Okay, we use the formula P is equal to F over 1 plus R over M raised to M times T. Again, we just need to substitute this following given to this equation. And we will have present value P is equal to 6,700 over 1 plus 0.10 over 2 raised to 2 times 3. Okay, just press that in your calculators and you should get P is equal to 4,999.64. That is approximately equal to 5,000 pesos. Alright? Next, example number 7. If 10,000 pesos is deposited in an account earning 5% compounded monthly, how many years will it take for the investment to become 10,777.16 pesos? Okay, what are the given? We have future value F, 10,777.16 pesos. Okay. Present value P, 10,000 pesos. Nominal rate R, 0.05 or 5%. M is equal to 12 for monthly. It says here compounded monthly. Okay? We are required to solve for T. We are asked how many years will it take for the investment to become this value. Okay, let's solve for T. For our solution, we can use the formula N is equal to log of F over P over log of 1 plus I. We were already able to use this formula in example number 3 of this lecture video. Remember, I told you to take note of this formula and add it to your list of formulas. Okay, now we know that I is equal to R over M. So we simply replace I with R over M. Okay? And then substituting the given, we will have N is equal to log of 10,777.16 over 10,000 over log of 1 plus 0.05 over 12. Just press this in your calculators and you should get N is equal to 18. N refers to number of interest periods, so we have here N is equal to 18 interest periods or months. Okay, how did we know that the unit is in months? It says here compounded monthly. Okay, we know that N is equal to M times T. We are asked to solve for T. So T is equal to N over M. That is 18 over 12. T is equal to 1.5 years. Okay. So how long will the investment take to become that amount? It will take 1.5 years. Okay, that's it for now. In our next video, we will still be solving more problems about simple and compound interest. That would be our fifth and final video for this topic. For more related practice problems, you may use our QuexBook General Mathematics app available from Google Play Store and answer Chapter 4. Thank you everyone for listening and God bless.